Good morning everyone. I am Tanushri Rai from Civil Engineering branch. So in the last class, we were calculating a numerical regarding strength of the tension member. So let us start from the block shear portion. So here you see along the V line, that means the horizontal line of the block shear portion is given by 1, 2, 3, 4 and here half and here is half. So total is 5 numbers of bolt holes are there. So we have to deduct this bolt hole area portion from the total width of the block shear portion along the V line, that means along the horizontal line. So here from the total width of the block shear along the V line, which is 160 into 2 minus numbers of bolt is 5 multiply by diameter of the bolt hole, which is 22 for the 20 mm dia bolt. Hole multiply by thickness of the plate section, which is given as 10 mm. So now calculating all these things, we got the value of AVN as 2100 mm square. So now comes to the area of ATG and ATN. So I told you, whenever we have to calculate the area along ATG and ATN, we have to consider the vertical line or the vertical section of the block shear portion as T. So first of all ATG, which means the cross section area along T line. So here from this point to this point, the total width of the block shear portion along the T line is here to here, which is 60 mm. Okay. So now 60 is the width of the block shear portion along T line multiplied by thickness. So thickness of the plate is 10 mm. So by calculating this, we got the value 600 mm square. So ATG value is 600 mm square. So now comes to ATN value. So ATN is similar to AVN. So we have to deduct the block shear portion, the number of bolt holes along the T line from the total width of the block shear portion along the T line. So the total width of the block shear portion is 60 along the T line minus the number of the bolts are, here is half and here is half. So total is 1. So 1 into diameter of the bolt hole, which is 22. So 1 into 22 whole multiplied by 10. So by calculating this, we got the value 380 mm square. So ATN value is 380 mm square. So now we can calculate the block shear as TDB1 and TDB2 as shown in the code book. So first of all, we will calculate TDB1. So the formula is AVG into Fy divided by root 3 gamma m0 plus 0.9 ATN Fu divided by gamma ml. So AVG we got 3200 multiplied by Fy is 250 divided by root 3 into gamma m0 is 1.1 plus 0.9. ATG we got 380 multiplied by FU is your 410 whole divided by 1.25, which is the value of gamma ml. So by calculating all these things, we got the value of TdB1 as 560.11 kilonewton. So after that, we have to calculate TdB2, which formula is ATGFY divided by gamma m0 plus 0.9 AVN FU divided by root 3 gamma ml, which equal to ATG we got 600 mm square multiplied by Fy, which is 250, and gamma m0 is 1.1. Again 0.9 multiplied by AVN, which we got 2100 multiplied by Fu, which is 410, whole divided by root 3 gamma ml, which is 1.25. So by calculating this formula, we got the value of TdB2 as 494.27 kilonewton. So we know that the strength of the block shear in case of plate section or tension member is the minimum of TdB1 and TdB2. So the minimum value is here 494.27 kilonewton, which is the value of TdB2. Hence, the block shear strength of the plate section is 494.27 kilonewton. So now, according to all the three values of the strength calculation, the minimum value of the strength will be the value of strength of the tension member. So, in the first strength calculation, that means the strength in yielding, we got the value 454.55 kilonewton. And second calculation, which is strength of rupture, we got the value 460.51 kilonewton. And third, which is the block shear strength, we got the value 494.27 kilonewton. So the minimum value is 494.27 kilonewton, which is the strength of the plate. So now we have to calculate second half of the calculation, which is the strength of the bolt. So we know that to calculate the strength of the bolt, we need to calculate the strength of the bolt in shearing as well as in bearing. So first of all, we have to calculate the strength of the bolt in shearing. So we know the value of the design shearing strength of the bolt is VDSB equal to FUB divided by root 3 gamma MB multiplied by NNANB plus NSASB. So because it is a plate section which is connected to the gusset plate, so it is the kind of lap joint. So for the lap joint, the NN value is always 1 and NS value is always 0. And ANB is calculated as 245 mm square, as you know, and ASB is 314 mm square. So now just put this formula and put the values. So here is the values, which is 400 divided by root 3 into 1.25 multiplied by 1 into 245 plus 0, which equal to 45.26 kilonewton. So, in this case, the numbers of bolts are 6. So, for the total design strength in shearing, we have to multiply the numbers of bolt with the design shearing strength. So, 6 into design shearing strength is 45.26, which equal to 271.56 kilonewton. So, now comes to second part, which is design strength of bolt in bearing. So, in case of bearing, the formula is VdPb equal to 2.5 kb dt Fu divided by gamma mb. So, here we need to calculate kb first, which is the minimum of these four values. So, first one is E by 3d0. Second one is P by 3d0 minus 0.25. Third one is FUB by FU. And fourth one is 1. So, by putting the value of E and D0 here, we got the value 40 by 3 into 22 as 0.606. And in the next formula, which is P by 3d0 minus 0.25, we got the value 0.659. And in the third case, FUB by FU, that is 400 by 410, we got the value 0.976. And fourth one is your 1. So, the minimum value of these four is the value of kb. So, which is 0.606. So, we will take the 0.606 as the value of kb. So, now we will put this value over here. So, 2.5 into 0.606 into d, which is the diameter of the bolt, which is 20. Then T, which is the thickness of the plate, which is 10, and Fu, which is 410 Newton per mm square, whole divided by gamma mb, which is 1.25. By calculating all this, we got the value 99.384 kilonewton. So, here also in the question, the numbers of bolts is 6. So, now multiply the numbers of bolt by the design strength of bearing. Hence, the total design strength of bearing is 596.30 kilonewton. So, now the design strength of bolt is minimum of design strength in shearing and design strength in bearing. So, here is one strength value and here is another strength value. So, the minimum of these two is 271.56. Hence, the design strength of bolt for this tension member is 271.56. So, in this way, the design part of this plate section is completed. So, we will discuss another problem in the next class. So, today this much. Thank you.